see if I click out and
Yeah.
you're still seeing, this is the YakCon page, you're seeing it, right?
Yes, and I just started recording.
All right. All right, so what I wanted to do was have a very quick discussion on the activity I'm planning for my track at YakCon. So if you haven't yet looked at it, it's basically 2 Sunday sessions of 4 hours with a week in between of asynchronous activities. And it looks like the agenda is like this. So start off with some overall introduction, a couple of guest speakers, then 25 minutes of introducing the tracks, and this one is the one I'm doing. And since I can't do 2 tracks, I'm doing a combined one for distributed systems and robotics. So trying to introduce both the rover project and the Monday distributed systems group. And the way it's structured is there's going to be 2 breakout activity sessions after the session intros. So this each is 50 minutes. I need to update this, but yeah, so there'll be 2 50-minute sessions basically. Then you have a week of asynchronous stuff. And then part 2 is the next Sunday, which has the same structure. So yeah, breakout activities A and B. So I have to do some editing here, but let's go to the actual page I made here. Okay, so here's the idea I had in mind. I thought since distributed memory is an interesting topic with some relevance in the Venn diagram intersection for both distributed systems and robotics, that would be the theme. So I have a theme here. And so I'll start off by introducing the 2 projects. So this is the Robotics Garage project, which really only has YakRover as the big active one. The other 2 are just starting up. So I'll just click around and show people these pages so they know where to look for more information.
Well, just one second.
Okay.
When you say YakRover, you folded in a lot of different things. I think you should look at it differently. For example, the Mars Garden is also a project. Yeah, maybe it didn't get anywhere, but just as an example, we have the tailspin thing we're putting up. We have that language for API for whatever. I'm not sure, what level of detail you want to use, but when you say YakRover, so you just put too much.
So this is the current stage of the stub page I made a couple of weeks ago. And the only ones I've broken out, I think YakRover is the big bag project with all the other things like Mars Garden. And these 2 have broken out since we only started talking about it recently. So the tail scale for robotics is an empty page. And then robotics simulation is also an empty page. So it's kind of like just scaffolding. So all the other stuff you've talked about is just here. So I was just going to spend maybe 3-4 minutes talking about bits and pieces. So I haven't actually come up with what to say, but yeah, I'll mention some highlights of what we've done. So I'm not quite sure how to do that, but I don't want to spend too much time introducing the projects because I want to get to the activity. So the plan is give them a quick preview in the live session, but then through the week in the asynchronous activities, there'll be opportunities to show more. And actually, let's see. So same thing with distributed systems study group, like show them what we've been discussing for the last year or so and what we are starting to discuss now, which is memory. Okay, but the actual activity, since we have 2 Sundays with 2 sessions each, here's what I had in mind. So the theme is memory, and the first Sunday I thought we would do as a kind of intuition pump, so give people a hands-on activity to kind of like feel their intuitions with the problem. And then the second session will be a reading and open-ended discussion. Then the asynchronous week, I thought both the channels and keep it simple. Every day we share one paper, maybe from our archives or a new one to get people up to speed. And people can just have open-ended discussion. And the option is to attend our regular meetings, which, as far as I know, will still take place. So we'll still have our Monday morning distributed systems meeting and the Tuesday rover meeting, so they'll get a chance to see a regular activity as well. And then the next Sunday, the 2 sessions, I thought
you go back to the activity?
I'll go into it.
No, I don't mean the details. I'm just trying to understand, are people doing it by themselves or they're doing it with others?
Yeah, let me get to that after just cover the whole
Okay,
structure to
okay.
see why I'm doing it this way. So the first Sunday activity, like I said, is an intuition developing toy activity. And the second Sunday is hopefully they've had a week of discussing more real world things, reading about like real memory architectures and things like that. So the discussion will be basically real world discussion, like not a toy problem. How would we actually build real world distributed memory for robots on Mars or Earth or whatever? That would be session 1. And session 2 would be kind of like paper design exercise of how would you actually design a network memory protocol that we could actually build. So that would be at the level of abstraction of, say, our tail scale experiments going on now. So that level, which can actually be built. Okay, to get back to the question you're answering, my initial thought was people do this as an individual activity for 20 minutes and then come back in and discuss for 30 minutes. So kind of like our discussion group structure. And just to give you an idea of where this problem is coming from, I think I may have mentioned this classic paper before on the power of the compass, 1977. Let me share this tab.
Yeah, you did.
Okay, so the basic idea is it's a kind of like visual way of thinking about graph searches. You have a bunch of pebbles that you can drop around, and there are proofs of how many pebbles you need to search the whole graph. But this to me seems like a good intuition pump. And I don't want to have them read or discuss the paper initially. I want them to actually just try this out on paper. So I'll flesh this out a little bit more, but I'll make a diagram of like, 20 by 20 grid with like example coloring like the paper itself has. And then just tell people, how do you actually just solve this problem? Imagine you have a bunch of like very primitive, tiny micro rovers with very little processing power and no memory, but they're carrying, say, 10 pebbles each. How do you get them to coordinate and explore the whole maze? And give them like a stateless kind of activity. So really all they have to do is maybe sweep away some trash from the trails or deactivate mines or something like that. So there's no need to actually remember what you're doing.
I still didn't understand. Each one has a set of robots, or each one plays a robot?
No, they're each working out how they would solve this problem on paper. So they might, so what I expect them to come back with is something like, all right, my strategy would be each rover will carry 10 pebbles, and whenever it comes to an intersection, it'll drop 1 pebble if it's going left and 2 pebbles if it's going right, and then it'll explore the maze that way. And then they'll explain why they think that algorithm would solve the problem. Does it make sense? So they're brainstorming a solution to the problem. They're not like role playing or anything.
Mm-hmm.
So again, the point is not to come up with workable technical solutions to the problem, but just to develop intuitions. And then you can go into the second session where they can spend maybe 15, 20 minutes reading the paper and getting a sense of how difficult it actually is. And then thinking about, all right, how would you actually do this if you had like, months to program a simulator that works this way? So that's the sort of, this would be 2 50-minute sessions. So first session, hands-on paper exercise, get some intuition. Second one, get a taste of the literature and understand how the problem has been approached, historically. And then through the week, I'll plan on just basically putting a paper a week in both the channels, the rover channel, a paper a day in the rover channel and the distributed systems channel. So, things like, memory architectures, I don't know, what the hard disk on the Curiosity rover actually looks like. So mix and match. I haven't yet picked papers, and maybe I'll keep it as a surprise and not reveal it all up front. But the idea is if they come back the next Sunday, they'll have both the sort of toy problem level intuition and a week of like letting it simmer and think about it, and then they'll be able to like actually talk about the problem. I don't know, more intelligently at an engineering level. Like, how would you actually build a shared distributed memory system for a fleet of rovers in a tough, unreliable environment? So anyway, that's the exercise. And I think so far about 30 people have registered for YakCon. So I'm expecting maybe 5 to 8 people will sign up for this session. Oh, and the other thing I wanted to point out is I do want to like leave it friendly to people with both technical and non-technical backgrounds.
Exactly.
So
How you got to help the non-technical people. They're not used
yeah.
to thinking out algorithms.
So for the, I'm trying to think of a version of this problem that I can restate in a way they can think of as like a children's game, for example.
So
Yeah.
let me help you. I have an idea.
Yes.
You have an example maze that they can print out, and you tell them to take M&Ms in 4 different colors. Each color is a different rover, and to take chess pieces and move them around and do whatever they want to do with the pebbles as they go through the maze.
That's a
In
good
other words,
idea.
give them the tools to make it real. But they should use the small M&Ms or even Skittles, not the big ones with peanuts, because, you know.
So it might take a little prep, and if they don't have a printer or something, I'll try to come up with one where they can do this on an Excel spreadsheet, for example. That might actually be easier. Oh yeah, that'll work.
Yeah, it's easier, but it's not as tactile. You know, you don't feel you taking them out of your hand. And then
I have a printer, and I suspect most people will be in places where they'll have printers, but spreadsheet version as an option in case they don't. Okay, and I guess they can be combined. So people can either just play the sample maze or think about the algorithmic version of the general problem. But on the discussion session, this paper is fairly technical, even if you just want to browse it. So the option I have is this very nice talk by Keith Krutler on memory. So she talks about like distributed place memory and how cultures use like embodied environments as a way to like create memories. So choices of 2 things to read, and both are kind of like similar topic, so it should have a good discussion. And yeah, for the asynchronous week, I'll try to mix in less and more technical readings.
So I don't know if this is a relevant time to talk about it. I'm reading a book, science fiction book from 2 decades ago called Wheelers, and the relevant part is that you have beings on Jupiter. That's not the important thing. They're very long-lived, and they come together in a conclave to make decisions. But after they've made the decision and they come apart, they remember being part of the conclave. They remember what decisions they made, but they don't remember how they made it or what the justification was. And I'm bringing that up because that's on the intersection of distributed and memory. Their memory works differently when they're separate and when they're together. Okay, and it's similar to what we usually think about, you know, the system knows. In other words, each individual robot doesn't know, but the system knows. So here, he was actually putting them together in one room, and when they're in one room, it's a working system. And when they separate, some of the memory remains and some does not. And one of the reasons I'm bringing it up is because of this mechanical side of coming together and going apart, which is relevant for rovers and less relevant for, you know, distributed computer systems.
You said this is a novel?
Sorry?
Is this a novel or a short story, or what is it?
It's a novel. It's a novel.
And what's it called? I'll see if I can find
I'll put the link on the chat.
I'm wondering if there might be a good review that we can use as one of the daily readings.
No. This is a side issue. You know, when he's describing the world, he's, you know, talking about it.
Are you planning to attend the sessions? Because this sounds like it would be interesting.
I'm planning to attend the sessions. Just a second. How do I put something in the chat here?
Is there a chat? Oh yeah, there we go.
Yeah. Oh, Zoom records the chat. Teams does not. Yeah.
All right.
I'm not talking about Zoom being better than Teams. I'm just talking about features we might have thought we liked and we don't, you know.
If you let's whose screen is it recording? If we leave the chat panel open, will it actually record the screen of the chat itself? I know some things do that.
I don't think it's recording anybody's screen. I think
it's just in the feed itself.
Calculating what it wants to do, but I have actually no idea.
Okay, let's see how the footage comes out. All right. So yeah, I think we'll have plenty of discussion time, both for the hands-on exercise and the paper discussion. So there'll be sort of opportunities to share this kind of like reference thing, like this science fiction story. Ian Stewart. Oh, isn't he a mathematician who's written pop?
Yes, he is.
I think I have a book of his on symmetry or something. Okay. All right. Yeah. So, and of course, if you guys can make it to any or all of it, that would help.
I didn't quite understand what happens after 20 minutes. No, Anuraj, we can't hear you.
We go around the room, everybody shares kind of their approach to solving the Pebble problem, and then discuss in general sort of the characteristics of the problem. And
so here again, it could take a long time for somebody non-technical to explain the algorithm and maybe showing it. So if you aim your camera at your paper with M&Ms on it, you can show how it's done. So, you know, you show it and then you tell what was your inspiration or what problem did you have doing it or whatever. I can't guarantee I'll have M&Ms left by Sunday, but you know.
Okay. I'll make a note to make that a cue or prompt to aim camera at the physical map if they do it that way. But yeah, in general, I think this is kind of a nice complement and segue into what we're currently talking about in the main track of the rover meetings. So we haven't explicitly talked about the tail scale stuff and how that relates to like shared memory or how we might do like, I don't know, a shared virtual file system or something like that. But this is a good lead into that kind of topic. So if you had a tail scale type network with a bunch of different devices and robots, each with some, I don't know, RAM and persistent storage and certain pattern of like interconnectivity, what's the most powerful memory abstraction you can build on top of that like shaky physical foundation? So, Rhett, do you have any insights into how far you can get?
It depends. Can you hear me?
Yeah.
Oh, cool. Well, I think it's certainly a very like generalized problem of like how do you store things in a distributed manner that makes it resilient to some of the members not always being around. And so I think there's a lot to sort of borrow from general distributed systems theory kind of stuff. But I think the hardest part is like, what are you going to store? And like just knowing the thing helps with finding the solution, I think. And now I either can't hear or you're muted.
No.
I'm muted.
There we go.
I think for distributed robot systems, the heaviest load data will be images and video clips. That's going to be the core of it. So in the example problem of like the Pebble automata, a real world version would be things like, photographs of wherever the individual rover is, like if it's doing mine sweeping or trash sweeping, and pictures of its activities as it goes along, something like that. So
I feel that what you're talking about is having factoids, some stored in one place and some stored in another. It's like if you have wedding pictures, some will be on my cell phone and some will be on yours. But we're talking about a distributed system. I think it's, Anuraj, when you want to talk, and if we hear you, we'll say something.
Yeah, is it working now?
Yes, it is. So, what I would think is more interesting is a memory system where the fact that it's distributed helps the rovers do their job. So, for example, if we store skills on different rovers, and then the question of the, let's call it API, how do you find the skills you need and access them in a way that's suitable for you? Okay, it's not just data. It's data that has to do with how a rover operates. And of course, you want to have some sort of soft fail mechanism. Okay, I'm just thinking we should steer towards, when we talk about tail, so we should steer towards, if we want to build one of the mechanisms which is especially relevant for a distributed rover system to share their memory, but the memory that they use, the skill memory, not the episodal memory. What is required of that? How fast do you have to be? How reliable? How searchable? I'm not even sure what the questions are. That's what I think we should focus on.
Does the term service discovery mean anything to you?
Yes, and I think that's getting close. Okay, but I still, like I said, I don't want it to be like, well, we have 20 services and we divided it up among the robots, and now how do you find the service that you want? Because that's just, a wedding pick.
There's a tool that I've used a few times. It's called Console. That you typically only use it on something like in a data center where you've got high connectivity between the nodes, but it's effectively just a distributed database. But what's stored in the database is essentially what service is running where, and then on any client in this distributed network that it creates, you can say, I want to connect to service, let's call it camera. You connect to camera and it will distribute, it will send your request to any service that has registered itself with the name camera based on some like routing, I think there's some amount of, do you want to be closer or further away, that kind of thing. And then as part of that, you've also got like the idea of like, is the service actually available? And so like, if you've got 100 different computers, they're all offering this one service and 10 of them are rebooting at the time, it's smart enough to know that, it's not actually available on that service because it's no longer, around. So I could imagine doing something similar on a rover and saying like every rover has this, joins this distributed system that is essentially a shared memory. It is literally using the Raft protocol to enact create a shared memory store.
But it then needs a central server, right?
It does not need a central server. That is the coolest part.
I've the opposite, let's call it complaint. It's an abstraction. You're abstracting away the fact that we're distributed when you do that. Okay, and it seems wrong for the problem we have.
You're abstracting away Sorry.
Yeah,
Now
it's
that I'm
like
in a tab, there we go.
I have a directory, I connect to the directory, and I get the service. The fact that you managed to make it distributed, that's great software, okay? But I don't even know that it's distributed. The whole purpose of the system is to make it not be distributed. While Tailspin or whatever it's called, it's telling you that we have a distributed network, that things are in different places with different capabilities, and it really matters, where you are and how far away you are. So I don't think that we can expect to have that quality of, I don't know, surface.
Are you saying you want, sorry, I got confused there. You're saying you want to know about the distributed nature of the services, not to have it abstracted away?
No, I'm saying I don't believe we can avoid it without paying a very, very high price, and therefore a solution which abstracts it away is probably not the right solution. Yeah, let me give you an example. Let's say the service is processing an image and looking for rocks that appear to have been in water before. Okay, typical thing you want to do on Mars. Different rovers, and there's only a small number of them, and they're heterogeneous, have different abilities to do that. One of them makes one type of mistake, another one makes a different type of mistake. One of them is only able to do 2 images, and then it has to do something else and a different one. And what makes the problem interesting is that they're not all sitting in one room connected with a gigabit buses or whatever and doing whatever they want to do. What makes it interesting is that they are different, they are limited, and if you connect to the one on the other side of the planet, it will cost you 10 times as much, and your bandwidth will be smaller. All of this detail, I think, is what makes it interesting. And when we take a solution which manages to ignore the detail, so the fact that it's a rover doesn't mean anything.
Well, doesn't that can you generalize the problem of roverness? The things that you're talking about is like a rover may be far away. It may not be doing its job very well for power reasons. It may be slow. Like all of these are like service availability questions. Like, is the service available and how well is it going to work and how far away is it going to be? So a service discovery mechanism that offers ways to route your request to an appropriate destination, if it can take into account these attributes, then that sort of is the same as what happens at a data center.
Yeah, well, in a data center, you have a lot of redundancy. So we can find me somebody to provide the service. I mean, you built it that way. And what I'm saying is that rovers on Mars don't have that redundancy.
Right. So the service is just unavailable.
No.
Oh, it's not?
It's partially available.
Okay.
That's the point. I mean, I expect most of the time not to get high quality service because it's just not available. And therefore, it's not, this is what I want. This is what I'm asking for. And I can get a little bit over here and a little bit over there. And yes, we're all on one network, but, it's complicated.
There's a related issue coming up. I don't know if this breaks the standard distributed memory abstraction or not. Think of like the Pebble problem. What that is kind of like a improvised persistent storage just made up in the environment, right? So you're making chalk marks on rocks, or you're dropping pebbles here and there. So if I were to look at it through your service discovery abstraction, assuming there's a bunch of networked rovers wandering around in that terrain, I would probably represent like pebbles in a particular region as services that are available through mediation by the nearest rover. So the equivalent of like, my wife is in the mall and I call her and say, can you check to see if this is available in the store? That kind of like you're on the spot, go provide the service kind of like protocol. So in this case, it would be something like we don't know whether that hill has been cleared of mines yet. So can you go and check the state of pebbles over there or something like that? I don't know if this works though. Like, how would you like represent things like chalk marks in the environment or like some partially known distribution of pebbles that you have to go there to find out? How do you represent this on like a computer network?
What you
Mars hard disk that you don't know without a address table? What is it?
maybe we don't understand the pebble game properly, at least me, but I understood that the only communication is by looking at pebbles. So the
Yeah.
pebbles are a type of semaphore, and there's no somebody who's nearby should take care of it.
Yeah. I'm talking not about the toy version now, but sort of the full engineering version inspired by that type of mechanism being part of it. So like superset. So now think of it as, all right, there's like other rovers that have gone. There are simple
like
rovers that. What?
Hobos used to mark places. Here the food is good. Here's there's a dog, and so on. So it's like hobo language.
Exactly. So it doesn't preclude the existence of more powerful communication mechanisms. So like, the Hansel and Gretel story of breadcrumbs to the witch's house. There, imagine like Hansel and Gretel are lost and somebody's searching for them with a group of people with cell phones. One of them finds a trail of breadcrumbs and says, hey, I found a trail of breadcrumbs. The kids probably went this way, right? So you can imagine overlays of like more primitive protocols that use like improvised environment modification by primitive rovers plus more complex rovers that have like a TCP IP network going, bandwidth limitations, things like that. Like, okay, here's an example. You're searching for a lost person in the forest with a rover, and there's some piece of proof, like, they've left a backpack with a bloody sweater around, and this is a piece of physical evidence that only a locally present entity can manipulate and interpret and analyze, right? So in this case, you can think of that pile of evidence as a hard disk that only the local actor can give you access to, but it's too hard to like actually translate it all into bits and convey to the network. So you have to ask something like, oh, does it look like a blood stain? Does it look like it's torn? Is the water in the backpack used up, right? So you're basically doing remote reads of that weird found hard disk. That's how I think of it. So, but the question I'm going back to is, how would you formally incorporate this into a tailscale like protocol where the node is a networked rover that might then be interacting with anything from a pile of evidence to a more primitive rover to a chalk mark?
Well, I mean, but that's a natural. In other words, each rover has private information and public information, and all the things you described are public information. You can ask the rover, is that a blood stain? And it's private information for that rover. Well, there's no geography involved, okay, in what I just said, which is a downside. In order to have geography involved, we would have to have the geography be nodes in the system.
Should we think of rocks as extremely dumb rovers? So no processing, one bit of memory, whether or not it has a chalk mark on it, that's it. So that's all it is. It's like an extremely primitive rover, and it's so primitive it doesn't even know it's a rover, doesn't have a name, doesn't have an address. But when another more sophisticated rover finds it, it can basically log it in the network and say, hey, I found a very dumb rover. Let's call it rover number 10. It's just a rock with a chalk mark on it, but I'm its local contact. Yeah. I think this is a way to create a very generalized open network into which you can add arbitrary artifacts as nodes.
So it's like in one of those graphical models of the world where each object can be acted on or can act on you. And with the rock, you talk to it by putting a chalk mark on it or racing it, and it talks to you by showing whether it has a chalk mark.
Yeah. And it can even take on some missions. You can pick it up and place it on the path to block the path, for example. Right.
So,
So
a highway is a distributed memory system where each milestone only knows what mile it's on.
Yep.
And that is very useful for somebody driving and who can sequentially query these milestones and gets this information.
Yep, that's a very good example. It's not a wild rock environment, but it's also not a smart environment with RFIDs and more complicated computation. It's just a set of mile markers with camera readable numbers on them. So yeah, I think there's sort of a, I don't know, expanded paradigm here that can basically accommodate the entire physical environment. This reminds me of, Anurag, you were talking about the affordances work. This seems related somehow?
I don't see how.
Yeah,
it seems to me like trying to model, like if you were to think about a 3D scene that you were modeling in a CAD program or just in like OpenGL or whatever, you have objects that are made of polygons, and the objects may be related to other objects, they may be tied together, they may have rules, and if you thought about the whole world operating that way, then everything is just objects. And they all have properties. And you can view the properties. But I don't know what you do with any of that. Like, that's I don't know. That's why I'm not sure where the conversation is going.
Just 1 second. Now you have to turn the rocks into nodes, meaning they have to be able to run Tailspin. But they can't because they're rocks, so somebody else has to run it for them. The point is that when you have a distributed memory system and different parts have a different memory capability, what makes it interesting is you can query them.
But you can't.
Of course you can.
They don't have computation.
But
no,
they're
I'm
not a computable entity.
Conversation. You're just not listening carefully.
What are we talking about? We are talking about.
Okay, let me explain. There's a milestone 10 miles down the road from here. If I ask you to talk to it, you have to walk up to it and see what it says on it. And you can then put a different number on it. Okay, you can't do it from here because it's 10 miles away and it doesn't have any network connectivity. Okay, but it's still a memory element and it's still storing information for the rovers. When I have a maze and I drop 2 M&Ms at one of the spots, I can see it, but the other rovers can't see it until they actually come there. So that's why it's a distributed memory. It has advantages, perhaps, but yes, you can definitely read and write. Isn't that all you require of memory? You remember the good old days when everything was on a tape, and if you called down to data processing and asked for a file, so they would look up which tape has a file and unmount the existing tape from one of the tape drives and put on the new tape and look for it. Actually, the computer would tell them to do it and they would do it. That's what we're talking about. It's a memory system.
And we can kind of like wrap it more formally with like a proper tail scale type node in a certain way. We can say that a more powerful rover or computer becomes its proxy representative, and the way it becomes a proxy is it maybe spins up a VM representing it with a unique address or something like that, and basically claims it as it becomes the exclusive agent for that. So when you address that mile marker, what's really happening is that a tail scale instance running on that VM is representing everything about it. Something like that.
Or it sends Anuvaj to look at the milestone.
Yeah. So
Takes a while.
I don't know if this is a clunky abstraction that doesn't do much, even though it might be theoretically possible, or whether this is maybe the alternate lesson here is it's too clunky to try and think of things like rocks and chalk marks as part of the compute environment, and we should really have a separate abstraction for them, like call it the environment and think of it separately, and the active nodes relate to it. So you have a threshold of compute capability, and below that you're part of the environment rather than part of the network. I don't know, maybe that's one an alternate way to think of it.
I think that's because we're too modern. If you look at Stonehenge, so Stonehenge is rocks, and it's definitely a memory device.
It's also a computing device because it can compute things like solstices and things like that based on the shadows of the sun.
Right.
Yeah.
That's one level up from just being a rock with chalk marks, is a rock that's positioned in such a way that together with the environment, you calculate something. So yeah, there's levels. That's one of the reasons why I like going down to the rock. Perhaps rock is the most simple memory item you have, other than existence. But you know, it's either there or not.
Yeah, Stonehenge could be seen as a very simple computer that has a fixed static memory of like, I don't know, a dozen bytes, plus a very simple static function call you can make, namely date and time, because it's got like, basically a prehistoric calendar.
Sundial.
Yeah.
Well, imagine a sundial that has on it 4 orange pips. That's exactly what you're talking about.
Yep.
The Jantar Mantar is a sundial, right?
Yeah, it's a sundial, and also what do they call that thing? That's that other device. Never mind, it'll come back to me. But yeah, all these are basically static sun position things. The compute element is the changing position of the sun and stars and moon. Even the long now clock, it's I think completely passive. It only uses like, I don't know, geothermal or some other energy, and it computes time in a purely physical way. Yeah, I'm at the moment I'm actually trying to design and make my own sundial.
Dover has a book on sundials, and that is a very good book with some very interesting designs.
There's a website that has free software that computes sundials for you. Share, it's kind of fun.
Yeah, okay, here's a book. Just a second.
Or Astrolabe, yeah. Astrolabe is the other concept. Think of it as like a sundial plus plus. So there's software. It runs only on Windows, unfortunately. So I'm planning to run it on a VM and see if I can design a sundial. So it does all the astronomical computations for you, and then you can sort of do the physical design and any creative embellishments. But yeah, I think there's definitely a spectrum from like unmarked locations, so like a wide desert where there's not even a rock as like a contained material object. And a rock is the simplest entity that can be object modeled. Then you have like sundial type things, and eventually you start having more and more compute power.
Okay, so let's imagine you've got a bunch of rovers living on the same planet. If they had a shared coordinate system, like in 3D space, you could query the fleet to say, in this polygon in the real world, is there anything there? Like a rock? And any rover that already had that that reality cached in
Cache.
in their own computer memory could either answer it that way, or they could say, I can go to that location to like look at it. And they can also mutate that environment and store things in it, both in the cached memory, like this rock has this written on it, or you can literally look at the rock and update your view of reality to see that it has something written on it. So in that way, if there was an API that was based on coordinate systems in reality that say like, you could access this memory, that is not a memory, but it's, I don't know, space.
It is a kind of memory, and I think I like your formulation because it's more, I think, practical than treating each as a uniquely identifiable sort of node, which has its own sort of, which controls its own agency. Here, it's more stochastic. It's like whoever conveniently happens to have cached a recent, I don't know, slice of reality, or is close enough to go read the current state, give me an update. It doesn't say that this particular rover is running a Tailscale instance that proxies that rock or something like that. So that seems to be like theoretically interesting, but not a practical solution. Whereas this is more like an auction marketplace of, I don't know, just-in-time reading of the environment. And yeah, I think partly it's a full 3D coordinate space, but I do think there's something about object boundaries. So the reason a rock is an interesting primitive is it can be picked up, it can be moved, it has a boundary, it has an integrity. You can say whether it's still a hole or somebody has smashed it with a hammer. And the techniques that work for representing rocks, I think, will fail if you're talking about like much more extensive natural environments. Like, you know, a lake is just too extensive in space, and it's probably not good to model the whole lake as a single entity. Or, you know, the entire Sahara Desert, you could potentially model it as one thing, but not a useful thing, I think. So, yeah, so I would say you would model the environment as locations plus bounded objects. So a rock is both an X, Y, Z at its center, as well as like, you know, a polyhedral shell defining its boundaries. So I think, yeah, position and boundary might be a good way to think of it. And then you put like some practical engineering constraints around, all right, the boundary can't be 5,000 miles, because at that point you should probably be modeling it at a finer resolution.
Well, if you've got identifiers and those identifiers map to polygons, it's fairly maximally flexible. It's just a matter of like, what do you want to do with that identifier, and does that make sense to be a useful thing? And of course, like, the identifier can move in space, so you don't necessarily know everything about it.
Yeah, and for example, representing things that have more complex structure, like say Stonehenge, you would not want to represent that as like, you know, 50 arbitrary stones that just have X, Y polyhedra around. You would have to model the whole entity and say, this whole thing is a primitive computer and it fits within this box and it can do these particular function calls if you go there and look along that line.
Yep.
Yeah, this actually reminds me of how I did my polygon modeling for my postdoc work. I think I talked about it at one point. It's basically 2D maps with polygons representing arbitrary primitives. All right, so I guess we have 1 minute left, and yeah, I got the workshopping of my session idea that I needed. That's all I had. All right.
Yep.
And we're meeting next week as usual. Do we still want to use Teams or switch to Zoom? This is fine.
Yeah, I might need to try the actual app, but
let's see what comes out.
Yeah, the video footage quality might be the fork in the road here. If Anuraj says the video is crap, maybe we should.
Well, for video calling, it's fine. It's only that the collaboration thing, it gets weird.
No, I mean for your converting to YouTube postable videos.
Okay.
Yeah,
That it will just record, I think, whatever there is on the screen for everybody. So right now it will record.
Let's see.
But probably this will record Mayor's screen, so he will be in a small corner.
No, I don't think that's what it does. But how about we wait and see? Because if it records my screen, I'm very little. Okay?
Yes.
Venkatesh is big. You and Ved are the same size, and I'm really little. So I'm sure it's not doing that. I also see the chat open on the screen. Sure, that's not what we're gonna get.
All right.
But I'll send you a link.
All right. I'll make a decision later then. See you guys.
Okay.
Bye.
Bye.